trying to keep these videos to a minimum, so I'm trying to keep them under 10 minutes, and the last one was just about. So here we are, example 2. We've done all the work here. If you're jumping in right at example 2, then you're going to want to rewrite, rewatch example 1. Okay, so we're going to get right into it. We notice here that x is defined in terms of y, and also we're going to integrate from y equals 1 to y equals 4, and so we might as well go ahead and find dx dy. The temptation is to solve for y and then integrate with respect to x. That's a temptation, and it's valid, but let's just see how it goes here. If we run into some trouble, maybe we would want to switch gears. But our dx dy would be the derivative of the right side with respect to y, so we have 2/3, and we have y minus 1 to the 3/2. So we know we bring the exponent out in front, and we multiply by y minus 1 to the 3/2 minus 1, which is 1/2. Okay, so we get some nice canceling going on here, and we get the y, basically the square root of y minus 1, and again, just like the last video, I get kind of lazy here, but I look at this as maybe more efficient. Okay, so we have, we're going to square the left side, the middle, and the right side. We're square everything, and so we get dx dy. Oh, you know what I forgot? Sorry guys. I forgot to say, look, we're gonna we need to rewrite our formula because we want to rewrite it every time until we know we have it memorized. 1 plus dx dy squared dy. Okay, so integrating with respect to y, no big deal. Just make sure your limits of integration are in terms of y, and that x is in terms of y as well. Okay, or the function x is defined in terms of y. So again, we're looking for dx dy squared. We've got that. Now again, in general, the square root of something, when you square it, you get the absolute value of y minus 1, but y is between 1 and 4, so we don't need those absolute value bars. Okay, we don't need the absolute value bars because y minus 1 will be 0 or greater between 1 and 4. Okay, so we've got that. And now we go way back here, and we'll just fill in what we need. We have the integral from 1 to 4 of 1 plus y minus 1 dy. That's nice that those 1's drop out, because then we just get square root of y, and I'm going to rewrite that as y to the 1/2. Okay, and I know that the antiderivative of y to the 1/2 is y to the 1/2 plus 1, which is y to the 3/2. Okay, and then I could write divided by 3/2, but I really, again, I can just think that through. Since I have fractions, I want to write them as little as possible. But y to the 3/2 over 3/2 dividing by 3/2 is like multiplying by 2/3. Okay, and then we're going to evaluate that from 1 to 4. And we've got 2/3. Keep that out front. And we're going to put a 4 in place of the y. And we get 4 to the 2/3, sorry, 4 to the 3/2 minus 1 to the 3/2. Okay, and then we get 2/3. Now, 4 to the 3/2, if you just really want to see it better, rewrite that as 4 to the 1/2, or square root of 4 cubed, minus 1 to the 3/2, that's just 1. Now we've got radical 4, which is 2. 2 cubed is 8. 8 minus 1 is 7. So we get 14 over 3, but don't just walk away. Come on, just plug it into your calculator, and what are we going to plug in? Let's plug in the square root of y. Okay, so we know we have 14/3. Okay, let's put it over here. So that's what we want to plug in right there. No, we don't need that. And again, math 9. Okay, oops, quite worked there. Math 9, and we're integrating from 1 to 4. And again, we don't have a y on our calculator that we can use, our independent variable. That y right there is just a dummy variable. And so we have the square root of, we could use any variable we want. We'll use our x that we're used to, and then we get that. Now, is that 14/3? And you're like, okay, I think it is. Well, let's not just think about it. Let's go math, change our answer, math, enter, enter, And we get, yes, it is 14 thirds. So good, we got the right answer.